All right, these examples on the page before. We started off on Thursday talking about tables and how tables are going to be. Oh, I didn't even look at it this morning. Oh, it's not working at all. Thank you for checking it, Phil, or else we would have gotten quite warm. So x is just getting bigger and bigger and bigger and bigger, going to infinity, or x is going more and more and more and more negative, going to negative infinity. That's how the tables are different. But how does it work as far as algebraically plugging in? All right. Does anybody have a hypothesis? X is going to infinity, bigger and bigger and bigger and bigger values. Does anybody have a hypothesis as to what this would equal? Infinity? You're close. Half wrong. Why negative infinity? The exponent. Remember when we do degree tests, we always try to figure out and identify who's the strongest, what's the strongest, because in a sense, as x gets bigger and bigger and bigger and bigger, the strongest man wins. He's going to take over eventually. He's the one that takes over and determines the behavior, like as it goes to the right or as it goes to the left. So who, in essence, ends up taking over? The 1? No. The 2x? He's going to infinity, but who's going to infinity faster? This guy. So if you want to think about it, it would be 1 plus infinity minus infinity. And some people will be like, yay, it's just 1. But that's not even taking into account whatsoever that this guy is a 5th degree and that's just a 1st degree, regardless of the 2 or the 3. So in essence, this one is going to go to negative infinity, but because of the strongest man winning, and he has what sign in front? How about number 2? What would happen if you plugged in the square root of infinity? Half infinity? No. Infinity is not one number. What's infinity? Not even all numbers. Oh man, come on, buddy. Okay. Infinity is more of an idea, and all it means is ever increasing, especially positive infinity. So ever just expanding, bigger and bigger and bigger and bigger. So how could we think of this? What's the square root of 25? What's the square root of 256? What's the square root of 4,000? What's the square root of... What's going to happen to the answers if you keep square rooting bigger and bigger and bigger numbers? It's going to keep getting bigger and bigger and bigger. At the same rate? No. But where is it still headed? It's still increasing without bound. Infinity. Square rooting ever increasing numbers is still going to be infinite. So some of these can kind of be logical in the sense of if you don't have fractions and if you don't have to worry about division, and division can like reduce things and cancel out things, etc. Polynomials or even normal expressions that don't have denominators, well, those ones we're going to kind of try to use our logic on. But for ones where we do have fractions, that's where we need to think about our degree tests. So with our fractions, with our degree tests, you guys help me out. If degree of the top is greater than degree of the bottom, who's winning again? Top wins, right? Top wins, tie, and then bottom wins, right? Top wins, tie, and then bottom wins. So if the top wins, what's happening? Which one do you know better? If there's a tie, what do you got? Ratio of the leading coefficients. Put C-O-E-F-F. Something like that. Leading coefficients. Sorry, the O did not show up so hot. Now I can't spell coefficients. It's going to be coffee. You can tell what's on my mind. Okay, coefficients. Whoop. There you go. So therefore, I can say that the limit is equal to, or you can say y is equal to, we put an HA. That's what I'm kind of leading up to at the bottom. There is a horizontal asymptote at y equals L, but I am going to say check the sign. Just because you just steal the ratio of leading coefficients doesn't necessarily mean that the sign is correct. It could be that something funny in the expression itself. If you're going to positive infinity or negative infinity, it might mess up the positive to a negative or the negative to a positive. So check the sign. Who's this guy? What happens if the bottom wins? 0. Always, always, always. The limit's going to equal 0. The nice thing is I can say there's a horizontal asymptote at y equals 0, and I don't need to say check the sign because what's true about positive, negative, 0? Yeah, exactly. It doesn't matter. But there's one more case, and the one more case would technically be no horizontal asymptote. But if we're trying to solve for a limit, we can still give an expression. So if the top wins, there is no horizontal asymptote. The function's not leveling off. But if it's not leveling off, what must it be doing? Either or. Yeah, it's either going increasing or decreasing. It's either going to positive or negative infinity. What's the question mark mean? Check the sign. If the top wins, you're going infinity and beyond again, but you still need to check the sign and consider whether it's a positive or negative infinity. Check the sign. So the ones that we need to check the sign, it's really only when you have weird things like square roots and absolute values where you really have to be careful. But that's in the positive, negative infinity or the ratio of the leading coefficients. Some of you weren't able to see the bottom of the page. I'm sorry. I know some of our eyesight, it's a little bit harder to see little things. So let me zoom in on that really quickly. At the very bottom, if y equals L is a horizontal asymptote, then either the limit to negative infinity or the limit to infinity equals L. Now I'm actually going to do and or. It's technically not just or. It's technically and or, because they could be the exact same thing. They could be the exact same thing. But hey, you guys were studying for a forever quiz today, right? And as you were studying for your forever quiz, my eraser disappeared. Here it is. Didn't you guys study the graph of e to the x? Okay. Question, just thinking about the graph of e to the x, what would the limit as x goes to infinity be of e to the x? Why positive infinity? What's e doing as you go to the right? It's just going up. Oh, okay, that's just infinity. E to the x, if you go e to the 10, e to the 100, e to the 1,000, e to positive numbers gets huge. But what happens if you plug in negative numbers? Can anybody see this is the exact same thing? I know you can see the graph. But can you see this is the exact same thing as this? The limit as x goes to negative infinity of e to the x is the same thing as the limit as x goes to infinity of 1 over. Wait, 1 over? I don't get it. What happens if you plug in a negative? Oh. What happens with negative exponents? It flips it. It's a reciprocal, 1 over. So these are the same thing. Does this make more sense why this is equal to, well, look at the graph or look at this. What's the limit? This one makes more sense because who wins? The bottom wins. This one, why is it tricky? It's getting bigger and bigger. No, it has a negative. So sometimes what happens to the right, positive infinity, is super different than what happens to the left. So in this example, the limit to positive infinity, the limit to negative infinity, they were not the same. And so this would be an or case. Does e to the x have a horizontal asymptote at y equals 0? Yeah. Why? Well, because the limit to the left is 0. So only one of them has to have a limit. But every now and then, could you have both limits being the same? Guys, what's an example of a basic graph? Another one. I'm going to write up e to the x, especially for Thomas, and for Janelle, and for Ryan. Our example was e to the x. F of x equals e to the x. We looked at the graph, and we saw how the limit of e to the x as you go to the right, and the limit as you go to the left, were two very different things. To the right, that one was kind of easy because it was just positive infinity. The function was just getting bigger and bigger. To the left, we talked about how if you plug in negative numbers to an exponential function, it's really the same thing. Negative numbers mean the exponents go in the denominator. So we could put e to the x in the denominator and change it to a positive infinity. If you plug in, that's definitely going to 0. And what we said is, yes, there is an HA going to 0, but it's the OR case. This would be an OR, because not both limits are the same. So we could say that e to the x does have a horizontal asymptote at y equals 0. Has anybody thought of a basic where limits is an and? Both of them agree. What's another basic graph that has a horizontal asymptote where whether you go to the right or to the left, both sides level off? Which one? Constant? Well, he doesn't have a horizontal asymptote, sadly. Constant. There we go. He just, I mean, you're not wrong. He doesn't go to infinity or negative. It goes to a number. Yes, okay. The constant one, yeah, because he's only one line anyway. So I guess kind of, except he's weird because he doesn't really get closer and closer to it. How about another graph? Keep thinking, but that was actually quite clever. Yeah, 1 over x or 1 over x squared, either one. Because if you do 1 over x or 1 over x squared, getting the basic graph real quick, whether you go to the right or to the left, what's going on in this guy? Where's his horizontal asymptote? And so he would be a case where he would be an and. Because if you would go to the right or to the left, the graph is doing the exact same thing. So sometimes both limits are totally the same. Sometimes they're totally different, and we have to be able to look out for that. So let's look at these examples. First one, match them with a case. Match them with a case. Top wins, bottom wins, tie. Top wins, good. So when the top wins, there are like other ways of doing this, multiplying top and bottom by 1 over x to the 5th. It's kind of messy. But long story short, top wins. We look at the strongest of both. Top wins, we know, infinity and beyond, right? But what do we have to do? Okay. So I need you guys to think about, if we were to plug in positive infinity, the 7 is inconsequential, so is the 3. As we plug into here, what's going to happen if I'm subtracting 6 times positive infinity to the 5th? Bigger and bigger numbers raised to the 5th power. Negative. And then what's going to happen in the denominator if I plug in positive numbers? So what's my overall answer? Good, and you checked the sign. Now some of you might have guessed that just by taking, in a sense, the ratio. Well, danger, top wins. But by seeing the negative and seeing the positive, just be careful. Be careful and plug in. How about the bottom one? How about the bottom one? He's a big old cubed root. Maybe you guys couldn't tell that. He's a big old cubed root of the whole thing. Which one? Yeah, I agree. Because they're both under the cubed roots. They both have this weird, like, to the 1/3. And if you guys notice the strong ones, they're both x squared. It's going to be a tie. Now, hold on, look at your notes. What did I say about ties? Ratio of leading coefficients, but what else did I say? Okay, check the sign. So we can do the 5, and we can do the 8. And pre-cal would be like, just steal the signs and don't even think about it. But now that we have limits, we have to be careful because they can give us really tricky functions. But kiddos, what always comes out of a cubed root? Or should I say, is there anything that's not allowed to come out of a cubed root as far as positives or negatives? Or is everybody allowed? Yeah, because you can take the cube root of a positive. You can take the cube root of a negative. No big deal. Square root's totally different deal. But since negatives can come out, is it okay if I realize that this is a negative number and then I'm like, oh, but cube root of a negative would still be negative? Is that okay? And then the bottom's going to be positive and cube root of a positive is positive. So is it what you would expect it to be? And the answer on this one is yes. But let me just give you a quick warning. If for any reason one of these was a square root of a little bit different expression, we might be having some issues right now. And the sign might be different than it would naturally look just by taking the ratio of leading coefficients. But I have some tricky ones in just a second. So let's go ahead and try number 3 first. These ones are pretty straightforward. So the first one was a top wins, second one was a tie, the third one is a bottom wins. And this is a basic graph. It's 1 over x in your perspective. That's been shifted to the right 12, right? So maybe you guys just from the basic graph could figure it out, or you could look at it and say bottom wins, what's my final limit? 0. And looking at the grand old scope of things, if they were to ask you for horizontal asymptotes, wouldn't we say this one has an HA at y equals, and this one has an HA But what about the top one? HA? No, because he's just going to infinity. So forget him. Now, here's the struggle. I kept on telling you to check the sign. Here's a reason why you have to check the sign. I'm going to give you a second to write down the example. And as you're writing it down, I want you to be thinking top wins, bottom wins, or tie. As you write it down, I want you to be thinking top wins, or bottom wins, or tie. I think Mr. Krim is speaking. If you guys know Tegan's dad, he's the one with the really funny voices. He tends to do the sassy walking around thing. Almost always. I think it's him. What do you got? Top wins, bottom wins, tie. Ooh, I heard both. I heard bottom wins and tie. Don't do top wins. That's a bad idea. Bad idea. Why is it a... Does it make sense? It's a quadratic square rooted. Now, don't kill a puppy. Can we say that this is x minus 2? Wrong. Poor little dead puppy. But square root quadratic will be a linear something. Yeah, I can say that. And so in a sense, I can say, well, hey, these two are linear. And so if they're linear, some of you would have been if you had even gotten that far, you're like, okay, cool. So 3 over square root of 1. Dun, 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 dun. But here's the dilemma. The square root of a squared actually gives us an absolute value. And with absolute value, we have to be super careful because sometimes it can be a positive that was under and sometimes it can be a negative that was under. So I need you guys to instead think of 3 over 1, and you're totally right. But I need you to check the sign. So what happens if I plug in a negative infinity up top? I get a negative. What happens if I plug in a negative infinity squared square rooted? Yeah. So is it a positive 3 like it looks? No, it's a negative 3. Why? Because of where I'm going. The square root of x squared, sometimes the x's are positive that go in there, sometimes they're negative. And even though the degree is tied, the sign gets a little messed up because this guy's under the square root. But do you see how checking a sign saved us from getting the wrong answer? Now here's the struggle. Do you think on the test, both of these, the positive 3 and the negative 3, would have been there? And a 0, and a DNE, and a positive, negative infinity? Yeah. So you got to know your stuff, okay? Let's keep going. We're going to do these kind of together, kind of quick. But these are other weird things that can happen that make us need to check the sign. What do you guys think? Top wins, bottom wins, tie. Does that make sense? Absolute value doesn't change the degree. So yeah, it's a tie. So yeah, it's a tie. And as you're looking at it, right? We know it's a 3 and we know it's a 2, but even though we know it's a 3 and we know it's a 2, we're not in pre-cal anymore. They're giving us nasty expressions, so we have to check the sign. You guys take a second and check the sign while I close the door because the middle schoolers are going to be loud. Make a hypothesis what you think the signs would be. Then we'll check it and see if you're right. First one is a positive over a positive. Good. Because if you plug in a negative infinity, a negative times a negative is a positive, and absolute value is always positive. But on the bottom, if you plug in a positive infinity, it's a negative number over a always positive number, which means this guy is going to end up being. Does that make sense? Okay. And the weird thing of this one, guys, do you notice there was one function? It was the same exact one. Guess what? Guess how many horizontal asymptotes he has? He has 2. And what's the struggle if the AP was to ask you to find the horizontal asymptotes of that guy? Be 1, that guy would be 1, 0, none, etc. would be 1, but then both would be 1. Gotta look out. Sometimes if you go one infinity to the other, you might even get more than one answer, which is kind of crazy, but we're looking at much more complicated functions than we used to. All right, here's our last page. This homework due tomorrow by 7 a.m. As you guys are writing this last page, I have a little bit of sad news. I'm praying real hard, but I might have jury duty tomorrow. I won't know until after 7 p.m. tonight. So, if I am not here tomorrow, I will have a video from last year where you guys can grade the 1.6 homework. And I'm hoping and praying the video has the chapter review. If not, I will either, depending on the subplans, I will either record some sort of way of working through the chapter review with you, or I'll make tomorrow a work day on the hope and the prayer that I don't get actually put on a case. You guys can be praying with me. Please, Lord. And so if I can't in any way, shape, or form be with you either electronically on the video or myself, I'll make tomorrow a work day on the practice test, and then Wednesday I'll go over questions and the test will be Thursday. Does that make sense? Okay, so listen to the sub. Whatever they say tomorrow is where things stand. Is that good? Okay. If I'm giving you a video, it's because I have full confidence that you guys can take what we do in class or did in class last year and use it to still be just as prepared on Wednesday. But if I feel like it wouldn't be helpful or it wouldn't be enough, I will delay it, because I always say that this test is the most underestimated one. So you guys need as much practice as possible. There is a chapter review in the book if you guys haven't seen it yet. So for those of you that did start off on homework number 6, try to finish it and try to start reviewing tonight. Sound good? Okay. And if God works a miracle, they won't call me in. This is like a federal court thingamabob. So let's finish up these last 2 notes. For most trig functions, limit. Ooh, I'm sorry. Did you guys see what I'm missing? What's supposed to be down here? I'm going to put a little plus minus infinity, not because you can do both at the same time. You totally can't. And we've seen so many cases today, even like this one, where they're not always the same. But what I mean is if you're going to an infinity of a trig function, for most, the limit does not exist because trig functions oscillate. So quick example, if I was to give you the limit as x goes to positive or negative infinity of sine of x, sine leveling off at all? No. So he would be dne. But here's the crazy thing. What if I was to give you something like the limit as x goes to infinity of sine of x over x? Who would you guys say wins? Does sine win? Does he get bigger faster? Or is sine stuck? Sine goes in between 1 and negative 1. Who's able to get way bigger, way faster? Bottom wins. X gets bigger and bigger and bigger. Sine stays stuck forever. So bottom wins. The limit of that one is 0, even though the limit of this one is dne. And then this one, guys, you can actually get going if you want. I'm going to write up on the board exactly what's there. E to the x goes to infinity one way, but goes to 0 the other. And we have to keep in mind positive exponents versus negative exponents. One makes it bigger and bigger and bigger, and one makes it tinier and tinier and tinier. When you guys have it, get out of here. Homework number 6, 7 a.m. tomorrow. Sound good? Okay. If you don't mind praying about my jury duty, I know it's a silly little thing, but I would appreciate it. All right, cool kids, chapel day. I'll see you later. Bye, guys. Happy Monday. See you in chapel. Bye. Oh, 2 minutes, 2 seconds. Next door?
Yeah.
Can I stop my recording real quick and pull up notes?
We just had some tinning